Okay, I'm going to do a sample problem from the book for you that qualifies as a constant speed challenge problem. So, in your edition of the book, it's probably number 15, but in mine it's number 12. I have an older edition at home. And in this case, we have a bowling ball traveling with a constant speed that hits the pins at the end of a bowling lane that is 16.5 meters long. The bowler hears the sound of the ball hitting the pins 2.5 seconds after the ball is released from his hands. What is the speed of the ball? The speed of sound is 340 meters per second. So first thing we're going to do when we solve these problems is gather my information and draw a picture. So I'm going to start with my G. What are my givens in this case? Let me zoom out a little bit. Okay, so my given information is that I have a bowling ball traveling down the lane, so I'm going to draw a picture. Very, very important step is to draw a picture that gives you a visual representation of what's going on in the problem. I think, especially on these more challenging problems, it becomes very important because you have to have some help in visualizing all the different steps so that you don't make mistakes and that you don't miss something. So I know that the delta x, or distance of the lane, is 16.5 meters. First bit of information I'm going to need. Okay, I also know that the velocity is constant. That's important too, right? Meaning my acceleration is 0. So there's no acceleration in this problem. I'm given that the total time is 2.5 seconds. And that is the time for the ball to go down the lane, for it to hit the pin, and for the sound wave to travel back through the air so that you can hear that it hit. And we know the velocity of the sound wave is 340 meters per second. Okay, so really what I have here is two different problems. I have the ball traveling down the lane, and I have the sound wave traveling back. Okay, so the ball is going to have a certain velocity as it goes down the lane, and when it strikes, the sound wave is going to have a certain velocity as it goes back. But we can assume that the same distance is traveled by both the ball and the sound wave. So that's going to help us out. So let's break this into two parts. First, my unknown, what I want to find is I want to find the speed of the ball. So VB. That's my unknown. Okay? So let's set up some equations here that we can use. If I want to know VB, I got to know how far did the ball travel, my delta XB, and in what time did that take place. Okay, because this is a constant speed, just the overall distance, the overall time will give me that single velocity. But I have a second part. The problem is, I know this, right? This is 16.5, but I don't know this. So I got to somehow use the other information then to work backwards and find delta t of the ball so that I can find the velocity of the ball. And that's where I'm going to need to use my sound information, okay, and this total time. I know that the total time is going to be the time that the ball travels plus the time that the sound travels, right? That makes sense. So the time the sound travels now is related to the speed of sound and the distance over which it travels, which I both know. So let's set up my second equation, where the velocity of the sound is the distance traveled by the sound wave over the amount of time the sound wave takes. So we know velocity of the sound wave is 340, delta x of the sound wave is 16.5, so we have enough to solve for delta t of the sound wave. First thing I'm going to do is get delta t of the sound wave out of the denominator. You can do it other ways. You can inverse it and flip-flop. You can go over 1 and cross-multiply. I just multiply both sides by delta t. That's what I find easiest. And then I'm going to divide by Vs. Divided by Vs. I'm doing it in one step. If you want to take 2 steps, feel free. So delta t of the sound wave is delta xs over Vs. Now, once I've evaluated, or once I've simplified, now I evaluate, meaning I put in my numbers after I've manipulated my variables. So delta x is the distance traveled, or the displacement of the sound wave, which is 16.5 meters, divided by the speed of the sound, which is 340 meters per second. I have a meter over meter, 1 over second. The second goes to the top. And I'm left with 0.04853 seconds. Now notice, because I'm going to use this answer to solve for another answer, I don't round it off right away. I'm not using sig figs at this point. I'm just going to leave this answer in my calculator, because the more accurate the original solving, the original quantities you solve for are, the more accurate your final value will be. That'll become real important when you start doing Moodle problems. Moodle problems will have little small margins of error, but you have to make sure you don't round off too quickly, or that round off will propagate through your answers, and your final answer will be outside the limits of what Moodle allows you to be off. Okay, all right, how does this help me? Well, this doesn't tell me the ball time, but I know the total time is the ball time plus the sound time. So now that I know the sound time, I know the total time. I'm going to set this up and solve for TB. So TB, I'm going to multiply or subtract TS from both sides. So the ball time is total minus TS, which is 2.5 minus 0.04853. So the time that the ball is traveling down the lane is about 2.45 seconds. All right. Now I have all the information I need to find the speed of the ball, or the velocity of the ball, because I have the distance it travels. Now I have the time. So my final step here is to substitute in the distance the ball travels, 16.5 meters, divided by the time it takes, 2.5 seconds, meters over seconds, and I get a final answer that the ball is traveling at 6.73 meters per second. So, do I look my units check out? Yes, I have meters, I have over seconds, meters per second. That's a unit for velocity. Does it seem reasonable? Yeah, that seems reasonable, right? 6 meters per second. It takes about 2.5 seconds, a little less, to get down the lane. That should fit within your realm of reason. So this is my final solution. Notice, even though it's a constant speed problem, still takes 3 different steps. I had to find the time of the speed of sound, or the time the sound wave took. I had to use that to find the time of the ball, and then go back to find the velocity of the ball. So write out your givens, set up the problem, figure out what you're needing to solve for, find what you're missing, and then use the other information to come up with a way to solve for that and work backwards.